Good day everyone, my name is Christine J. Amalyari, and now let us talk about t-test 2 sample. A 2 sample t-test is used to determine whether or not two population means are equal. The following assumptions must be met for a 2 sample t-test. The first one is the data must be normally distributed, and the second one is the variances of the two groups must be equal. The primary purpose of 2 sample t-test is to compare means of two independent groups. The formula for 2 sample mean test is t is equal to mean sub 1 minus mean sub 2 all over the square root of n sub 1 minus 1 times s sub 1 plus n sub 2 minus 1 times s sub 2 all over n sub 1 plus n sub 2 minus 2 times the square root of 1 over n sub 1 plus 1 over n sub 2, with the degree of freedom is equal to n sub 1 plus n sub 2 minus 2, where mean sub 1 is the mean of sample 1, mean sub 2 is the mean of sample 2, s sub 1 is the standard deviation of sample 1, s sub 2 is the standard deviation of sample 2, and n sub 1 is the number of items in the sample 1, and n sub 2 is the number of items in the sample 2. Let us now proceed to example number 1. Sample of sales in similar shops in 2 towns are taken for a new product with the following results. The mean sales of town A is 57, in town B it's 61, and the standard deviation in town A is 5.3, and in town B is 4.8. The size of sample in town A is 5, and the size of sample in town B is 7. Is there any evidence of difference in sales in 2 towns? Use 5% level of significance for testing this difference between the means of 2 samples. In step 1, let us determine our null and alternative hypothesis. Our null hypothesis is sales of shops in 2 towns is same, and our alternative hypothesis is sales of the shops in 2 towns is different. In step 2, our alpha is 0.05, and the test that we are going to use is t-test 2 sample 2-tailed. Now, let us get our degrees of freedom by substituting the given sample size into our formula n sub 1 plus n sub 2 minus 2. Therefore, our degrees of freedom is 10. In our t-table, look for the 2 tails of 0.05 and degrees of freedom of 10. Now, look for the number where they intersect, and this is 2.228. Therefore, the tabular value will be 2.228. In step 3, using the formula, solve for the following values. So t will be negative 1.3646 or negative 1.36. Step 4. The computed t-value of 1.36 is less than the tabular value of 2.228 using 5% level of significance and degrees of freedom of 10. In step 5, therefore, we accept the null hypothesis. The sales of the shops in 2 towns is same. Let us now proceed to example number 2. A psychologist wants to compare stress level in 2 groups of people, those who meditate and those who do not. The meditation group has a mean stress level of 30, where n is equal to 10 and s is equal to 5. And the non-meditation group has a mean stress level of 35, where n is equal to 10 and s is equal to 7. Is there a significant difference in stress levels between the 2 groups at alpha 0.05? In step 1, our null hypothesis is there is no significant difference in stress level, and our alpha is there is a significant difference in stress level. In step 2, our alpha is 0.05, and the test that we are going to use is t-test 2 sample 2-tailed. Now, let us solve for the df So 10 plus 10 minus 2 is equal to 18. Now, look for the 0.05 in two tails and the degrees of freedom of 18. And the number where they intersect is 2.101. So, our tabular value will be positive negative 2.101. By substituting the given to our formula, our t is equal to negative 1.8380 or negative 1.84. In step 4, the computed t-value of 1.84 is less than the tabular value of 2.101 using 5% level of significance and degree of freedom of 18. Therefore, we accept the null hypothesis. There is no significant difference in stress level. Now, get a paper and try this. Suppose we want to know whether or not the mean weight between two different species of turtles is equal. To test this, we'll perform a two-sample t-test at significance level of 0.05. The sample size of sample 1 is 20. The sample size of sample 2 is 18. The sample mean weight of sample 1 is 300 and the sample mean weight of sample 2 is 305. The sample standard deviation of sample 1 is 18.5 and the sample standard deviation of sample 2 is 16.7. In step 1, let us identify our null and alternative hypothesis. Our null hypothesis is the mean weight between two different species of turtle are equal. And our alternative hypothesis is the mean weight between two different species of turtle are not equal. In step 2, the test that we are going to use is t-test. Our alpha is 0.05. It is two-tailed and the tabular value is equal to positive negative 2.028. In step 3, let us substitute our given values to our given formula. So our t is equal to negative 0.8708 or negative 0.87. In step 4, the computed t-value of 0.87 is less than the tabular value of 2.028 with 5% level of significance and degree of freedom of 76. And lastly, in step 5, therefore, we accept the null hypothesis. The mean weighted between two different species of turtle are equal.